Hello, my dear students. Today we are going to continue our discussion on chapter 2, which is chemical analysis. We are going to talk about the revision on chemical calculation, and we are going to discuss different types of problems. So let us start. Revision on chemical calculation. The mole. What do we mean by the mole? It is the amount of matter that contains Avogadro's number, which is 6.02 times 10 to the power 23 of atoms or molecules or ions or formula units of the substance. Now we are going to discuss what we mean by the molar mass. The molar mass, it is the molecular mass of the substance expressed in grams, or we can say the molar mass of the molecules. The molar mass of oxygen, to get the molar mass of oxygen where its atomic mass is 16, here the answer, the oxygen is diatomic molecule. Remember, my dear students, the molecule of element depend on the number of the atoms in the molecule, which depend on the physical state. So the molecules of elements at normal temperature are monoatomic, except 7 elements which are diatomic at normal temperature, which are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So oxygen is one of the diatomic molecule at normal temperature. So the molar mass of oxygen, so we have to multiply 2 times the atomic mass of oxygen, which is 16, so equal 32 grams. Now, how can we get the molar mass of carbon dioxide? We know that the formula of the carbon dioxide is CO2. It contains 1 carbon atom and 2 oxygen atoms, where the atomic mass of carbon equal 12 and atomic mass of oxygen equal 16. So we get the molar mass by getting the sum of these atomic masses. So molar mass of carbon dioxide equal 1 times 12 plus 2 times 16 equal 44 grams. The molar mass of sodium carbonate, which is another example to find the molar mass of molecule of compound. Here the atomic mass of sodium is 23, atomic mass of carbon equal 12, and atomic mass of oxygen equal 16. The solution here, we get the sum of these atomic masses that forming the molecule. So 2 times 23 plus 1 times 12 plus 3 times 16, so equal 106 grams. Now we are going to discuss the relation between the mass of the substance and its molar mass through several examples. Let us show on the screen. The mass and the molar mass, which is the mass of 1 mole. As shown on the screen, we have to find first the molar mass of the molecule, whatever it is, element or compound, then multiply it by its number of moles so we can get the mass of the substance. For example, we are going to discuss some problems. First problem, calculate the mass of 0.5 moles of bromine, where atomic mass of bromine equal 80. Solution here, we have to find first the molar mass of bromine, or the mass of 1 mole of bromine. So 2 times 80 equal 160 grams. Then the mass equals the number of moles times the molar mass, or the mass of 1 mole. So equal 0.5 times 160, so equal 80 grams. My dear student, we can use the cross multiplication ratio to solve this problem, as we know that 1 mole contains a molar mass. So 1 mole of bromine contains 2 times 80 equal 160 grams. So 0.5 mole of bromine contain X gram of bromine. So the mass of bromine equal 0.5 times 160 over 1 equal 80 gram. Another example. How many moles in 64 gram of oxygen, where the atomic mass of oxygen equals 16? Here the solution. The mass of 1 mole, which is a molar mass of oxygen, equal 2 times 16, as it is diatomic molecule, so equals 32 gram. Then the number of moles equal mass over molar mass, so equal 64 over 32, so equal 2 moles. We can solve this also by the ratio or the cross multiplication ratio. Here 1 mole contain molar mass of oxygen, so 1 mole of oxygen contain 2 times 16 equals 32 gram, so x mole of oxygen equals 64 gram. So here the number of moles equal 1 times 64 over 32 equal 2 moles. Another problem. How many moles in 27.8 gram of lead to chloride, where the atomic mass of lead 207 and atomic mass of chlorine equals 35.5? Here also we have to bring first the molar mass of the compound of the molecule of lead to chloride. So 207 plus 2 times 35.5, so equal to 178 gram. Then we have to get the number of mole by dividing the mass over the molar mass. So the mass given in the problem, 27.8 over 278, so equal 0.1 mole. Now we are going to discuss the relation between the number of particles, which are molecules or atoms or ions, and the mass of the substance, and the Avogadro's number. So let's start with the relation between number of particles and Avogadro's number first. The number of particles and Avogadro's number. Here the number of moles times Avogadro's number gives the number of molecules. So number of atoms equal number of molecules times atomicity. What do you mean by atomicity? Atomicity is the number of atoms in molecule. So the atomicity of nitrogen, N2 equal 2, and atomicity of phosphorus equal 4, and in the vapor state the phosphorus, and ozone O3 atomicity equals 3, and carbon dioxide atomicity equals 3. Here we are going to discuss some problem to show these relations. How many molecules and atoms in 0.5 mole of hydrogen? Solution. The number of molecules equal number of moles times 6.02 times 10 to the power 23. So 0.5 times 6.02 times 10 to the power 23, so equal 3.01 times 10 to the power 23. Then the number of atoms equal number of molecules times atomicity, so equal 3.01 times 10 to the power 23 times 2, so equal 6.02 times 10 to the power 23. So we can solve this also by the ratio or cross multiplication ratio. 1 mole contains 6.02 times 10 to the power 23 molecules of any substance. So 0.5 mole contain X molecules. So the number of molecules equals 0.5 times 6.02 times 10 to the power 23 over 1. So equals 3.01 times 10 to the power 23. And the number of atoms equal number of molecules times atomicity. Here 3.01 times 10 to the power 23, and here the molecule contains 2 atoms, so times 2, so equal 6.02 times 10 to the power 23. Next problem. How many molecules and atoms in 0.5 mole of carbon dioxide? Then find the number of carbon and oxygen atoms in it. Solution. The number of molecules equal number of moles times Avogadro's number, 6.02 times 10 to the power 23. So 0.5 times 6.02 times 10 to the power 23 equal 3.01 times 10 to the power 23. So we can solve this also by the cross multiplication ratio. So 1 mole contains Avogadro's number of molecules. So 0.5 mole contain X molecules. So the number of molecules 0.5 times 6.02 times 10 to the power 23 over 1. So equal 3.01 times 10 to the power 23. So the number of atoms of all the molecules equals the number of molecules times atomicity. So 3.01 times 10 to the power 23, as the molecule of carbon dioxide contains 3 atoms, so we have atomicity 3, so equals 9.09 times 10 to the power 23. How can we get the number of carbon atoms only? Here the number of molecules times the atomicity of carbon in carbon dioxide, which is 1. So the number of carbon atoms equals the number of molecules 3.01 times 10 to the power 23 times the atomicity of carbon, which is 1. So equal 3.01 times 10 to the power 23. And the number of oxygen atoms only in carbon dioxide equals the number of molecules times its atomicity of oxygen. So equals 3.01 times 10 to the power 23 times 2. So equals 6.02 times 10 to the power 23, which are atoms of oxygen, atoms in carbon dioxide molecules. My dear students, now we are going to discuss also type of problems which relate the number of particles and the mass of the substance. So look at the screen again. The number of particles and mass of substance. Here, if we know the number of particles and divide it over Avogadro's number, we get the number of moles. Then, when we have the number of moles times the molar mass, we get the mass of the substance. For example, here we are going to discuss some problems. Calculate the mass of 12.04 times 10 to the power 23 molecules of nitrogen, where the atomic mass of nitrogen is 14. Here, solution. The number of moles equal the number of molecules over 6.02 times 10 to the power 23. So equal 12.04 times 10 to the power 23 over 6.02 times 10 to the power 23. So equal 2 moles. Then we have to know the molar mass of nitrogen molecule by multiplying the atomic mass of nitrogen by 2. So 2 times 14 equal 28 grams. Then we can get the mass by multiplying the number of mole times the molar mass. So here 2 times 28, so equal 56 grams. We can solve this also by the cross multiplication ratio. The molar mass of nitrogen with 2 times 14 equal 28 grams contains 6.02 times 10 to the power 23 molecules. So mass x gram contain 12.04 times 10 to the power 23 molecules. So we can get the mass 28 times 12.04 times 10 to the power 23 over 6.02 times 10 to the power 23. So equal here 56 grams. My dear students, now we are going to discuss different types of problems which based on the reduction of cations that need number of moles of electron to be neutral. So we are going to discuss some problems on the reduction of moles of electrons to cations. Look at the screen again. The reduction by moles of electrons. Moles of electrons needed to reduce 1 mole of any cation equal the number of charges that found on the cation. For example, aluminium ion, which have positive 3 charge, gain 3 moles of electron to be aluminium metal. So 3 moles of electron needed for reduction of 1 mole of aluminium cation to form 1 mole of aluminium atoms. So problem for this, calculate the number of moles of electrons needed to reduce 54 grams of aluminium ions. where the atomic mass of aluminium is 27. Solution. Here 1 mole of aluminium ion contains 3 moles of electrons. So 27 grams of aluminium ion contains 3 moles of electron. So 54 grams of aluminium ion contain X moles of electrons. So the number of moles of electrons equal 54 times 3 over 27 equal 6 moles of electrons. My dear students, now we are going to discuss the relation between the molar volume or molecular volume and the molar mass. So look at the screen again. The molar volume or molecular volume. It is the volume occupied by 1 mole of any gas at standard temperature and pressure that we call STP, which equals 22.4 liters of 1 mole of any gas. Here the molar volume and molar mass relationship. The molar mass of any gas occupies molecular volume which equals 22.4 liter at standard temperature and pressure. What do you mean by STP or standard temperature and pressure? Here the atmospheric pressure equals 76 centimeter mercury or 760 millimeter mercury, and the temperature equal 0 degrees Celsius or 0 plus 273 equal to 73 degree Kelvin. For a gas at STP, at standard temperature and pressure, the volume of gas equal its number of moles times 22.4 liter at standard temperature and pressure. So we are going to discuss some problems on it. Find the volume of 132 grams of carbon dioxide gas at standard temperature and pressure, where the atomic mass of carbon equal 12 and the atomic mass of oxygen equal 16. Solution of the problem. The molar mass here equal 12 plus 16 times 2, so 44 grams for carbon dioxide gas, which occupies 22.4 liter at STP. Then 132 grams of carbon dioxide gas occupies X liter, so we find the volume of carbon dioxide gas equal 132 times 22.4 over 44, so equal 67.2 liter. Next example. How many moles of ammonia gas are there in 72 liter at standard temperature and pressure? Here the solution. 1 mole of ammonia gas equals or contains or occupies 22.4 liter at STP. So X mole of ammonia gas occupies 72 liter of ammonia gas. So the number of moles of ammonia gas here equal 72 times 1 over 22.4, so 3.2 moles of ammonia gas. Density, volume and mass. Here density equal mass over volume. Here the unit of volume is liter and the unit of mass is gram, and so the unit of the density equal gram per liter. The density of the gas and its molar mass. As we know that the mass will be molar mass if the volume which gas occupies is 22.4 liter at STP. So, for example, calculate the density of oxygen gas at STP or standard temperature and pressure, where the atomic mass of oxygen equals 16. Here, solution. The molar mass of oxygen, O2, equal 2 times 16, so equal 32 grams. So the density of the gas equal molar mass over 22.4 at STP, so density equal 32 of oxygen molar mass over 22.4, so equal 1.43 gram per liter. The mole and solution. The molar solution. It is a solution where each 1 liter contains 1 mole of solute. So we can say concentration in unit mole per liter or molar equals number of moles over the volume in liter. So the number of moles here equal mass of substance and over the molar mass, as we know this from before. Then the mass of substance equal concentration times volume times molar mass. So we can use this rule by writing mass over concentration over molar mass over volume. We substitute the number of moles by mass over molar mass, so we can get the concentration directly by dividing the mass over molar mass times volume. Problems. Calculate the concentration of sodium carbonate that resulted from dissolving 0.1 mole in 250 milliliter of water. Solution. The concentration equal number of moles over volume, so 0.1 over 250 times 10 to the power negative 3. Why do we make this multiplication? Because the volume must be in liter, so milliliter to change into liter, we have to multiply by 10 to the power negative 3. So equal here 0.5, so 0.4 molar or mole per liter, which is the unit of concentration. Next example. Calculate the concentration of sodium carbonate solution resulting from dissolving 53 grams of solid sodium carbonate in 250 milliliter of solution where the atomic mass of carbon 12, sodium 23, oxygen equals 16. Here, the solution here, we have to get the molar mass, then multiplying by number of mole to get the mass. So, the molar mass of sodium carbonate equal 2 times 23 plus 12 plus 3 times 16, so equal 160 grams. Then the number of moles equal mass over molar mass, so equal 53 over 106, so equal 0.5 moles. Then by dividing the number of moles over the volume, we can get the concentration or molarity, its unit mole per liter or molar. So the volume in liter first, we have to change the volume in milliliter to liter. So 250 divided 1000 or times 10 to the power negative 3 equals 0.25 liter. Then molarity or concentration equal number of moles over volume. So molarity equals here 0.5 over 0.25. So the molarity here is 2 molar or 2 mole per liter. Here we can say also the molarity equal mass over molar mass times volume. If you want to get the molarity directly from the mass, we have to apply this rule. Molarity equal mass over molar mass times volume. So equal 53 over 23 times 2 plus 12 plus 3 times 16, which is the molar mass of sodium carbonate times its volume in liter, 0.25 liter. So we can get the molarity here 2 mole per liter or 2 molar solution. Next example. Calculate the mass of potassium hydroxide required to prepare 500 milliliter of 2 molar solution where atomic mass of potassium 39, oxygen 16, hydrogen 1. Here we know that the mass equals the molarity times volume times molar mass. So the mass of potassium hydroxide equal to times 500 over 1000 to change the volume from milliliter to liter times the molar mass of potassium hydroxide, which is 39 plus 16 plus 1, so equal 56 gram. The weight percentage of element. The element weight percentage equal element mass over molar mass times 100. We are going to discuss some problems on it. Calculate the percentage of oxygen in sodium sulfate, where atomic mass of sodium is 23, sulfur 32, and oxygen equals 16. The solution. 1 mole of sodium sulfate here contains 4 moles of oxygen. So the percentage of oxygen here equals the mass of 4 moles of oxygen over the molar mass of sodium sulfate times 100. So percentage of equal 4 times 16 over 23 times 2 plus 32 plus 16 times 4 times 100, so equal 45%. Another problem, iron oxide ore. Ore, it means that we know from before compounds that contain impurities. So iron oxide contain impurities, what we call ore, contains 30% only hematite, which is pure. Calculate how many tons of ore needed to form 1 ton of iron, where the atomic mass of iron equal 56 and atomic mass of oxygen equal 16. Solution. As we know, 1 mole of iron 3 oxide contains 2 mole of iron. So 56 times 2 plus 3 times 16 here equal 160 grams of iron 3 oxide. So contains 2 moles of iron, 2 times 56, so equal 112 grams of iron. As we know that's the ratio, here we can say it 160 ton of iron 3 oxide contain also 112 ton of iron as it is ratio. So the X ton of iron 3 oxide contains 1 ton of iron as the problem. So we can get the mass of iron 3 oxide here 1 times 160 over 112, so equal 1.43 ton. Here this compound is pure, but we need the ore. So every 100 ton of the ore contains only 30 ton of iron 3 oxide, as the problem said that the percentage of oxide in the ore 30%. So every 100 ton of the iron ore oxide contains only 30 ton of pure iron 3 oxide. So here X ton of iron 3 oxide ore contains 1.43 ton of iron 3 oxide pure. So the X ton of iron 3 oxide ore equal here 1.43 times 100 over 30, so equal 4.7 ton of iron oxide ore. My dear students, we have reached to the end of our program today. I hope you understood all different types of problems that we discussed today. So till we meet again, my best wishes for you.